This video shows an analog experiment of caldera formation. The first part of the video shows how I constructed the apparatus I use in the experiment. Briefly, I constructed a see-through housing that I put a hose to that I could put air into so that I could inflate a balloon that would disrupt essentially flour, though there's other layers of material that I put in there. And I show how to create a stopper so that you don't make a mess when you insert your valve, and you can use additional balloons, different kinds. This was going to be an idea to use a smoke bomb to show pyroclastic flow or ash flow, what do you want to call it, just that. It didn't work out though because the fan didn't have enough pressure to inflate the balloon, so I had to just nip that. But here's the end result, a housed see-through bed where you can see different depositional layers. And this is where the experiment begins. And it's where I start to talk about calderas. Now, a caldera is, in its basic sense, a volcanic crater. And it's basically either caused by the collapse of a magma chamber roof or the explosion of it. From what I read, there's three kinds of calderas, an easy way to think of it. And that's a crater lake caldera, a basaltic caldera, and a resurgent caldera. Now, I'm going to start with crater lake calderas. This kind of caldera type is associated with Plinian-style eruptions, violent explosive eruptions that gradually empty the magma chamber. Generally, these calderas are created by crustal collapse above shallow magma chambers. This collapse is often associated not only with the generation of pyroclastic flows, but piston-like collapse of the volcanic edifice can generate the additional eruption of pumice-dominated sheet flows along what's called ring fractures surrounding the collapsing mass. These sheet flows form deposits of ignimbrite, which gives the typical caldera morphology of inflow and outflow facies that you can see in places like Crater Lake. These type of calderas can also be caused by stromboli eruptions, but it's a lot less common. The next kind of caldera is basaltic calderas. Now, these calderas are generally built more gradually and are enlarged by episodic collapse due to the extraction of lava from shallow level magma chambers underlying the summit areas. And these collapses essentially happen in increments, and they produce nested structures of pits and terraces. I've seen these types of calderas and the formation characterized in two phases. One is with the start of the first collapse. It's characterized by the largest collapse amplitude, an incremental edifice inflation, and a step-by-step increase in the rate of magma flow. And then phase 2 shows a rapid decrease in the discharge rate at low levels with continuous edifice deflation. A good example I found of basaltic caldera formation is the Erda Ale caldera in Ethiopia. The last type of calderas that you can understand is resurgent calderas, and they form when ring fractures occur at large scale and the primary events for outflow, which is pretty interesting. And the decomposition of magma results in massive demineralization, obviously, and the explosive eruption of tephra in the high atmosphere. And as the eruption wanes, pyroclastic flow begins to erupt from the ring fractures, and the magma chamber is depleted and its crustal roof begins to collapse, which generate additional pyroclastic flow. And the thing to know about these, they're a lot like Crater Lake calderas, only they're a lot bigger, and obviously ring fractures become the primary events. But they're huge, but I'm going to pause on that for a second. I added sand to line because I thought it would show more of the columnar fall that you see in a lot of calderas, because I was having too much intermixing with the flour. And then I thought maybe I could illustrate an example of a stromboli caldera, which is where the roof doesn't just collapse, but it explodes, creating an ash flow. And I pushed the sand line because it has surface tension in it, you can compress it. And I tried to put some side pressure on it, and I was right about to pop it when it actually popped by itself. But that's an example of a stromboli type eruption creating a caldera, as opposed to previously it was more the Plinian style. I wish the smoke was there, that would have helped a lot. But that's the end of the video. Thank you so much. Bye.